Okay, now just a brief summary of what we're doing here. If we're given V naught, VF, and delta S, we want to reason out delta T from the definitions. Then, from V naught and from V naught and VF, we can get the average velocity, or we could get the change in velocity. If we know the average velocity and delta S, we can find delta T. If we know the change in velocity and delta T, which we could find from here, we can get the acceleration. So there's a simple procedure, a simple reasoning process that will do this for us. We can do a schematic that shows us how the reasoning process works. If we know V naught and VF, we can put them together to get delta V. We can put them together to get V bar. And of course, if we know delta V and V naught, we can find VF. If we know delta V and VF, we can find V naught. Now, how do we do that? If we know delta V and V naught, we just add delta V to V naught to get VF. And of course, if we know VF and delta V, we can subtract V naught. When these form a triangle, that means there are these are three quantities that are related by a single equation that involves just those three quantities. A single relationship that we understand better and better every time we use the relationship, as long as we're thinking about what it means. Okay, well, other triangles form here. Our reasoning process, given V naught, VF, and delta S, is we can find delta V, we can find V bar. If we put V bar together with delta S, we can find delta T because, why? Because delta S is V bar multiplied by delta T, or V bar is delta S divided by delta T, which is the way the relationship is written here. Once we have delta T, we can put that together with delta V to get A. So right there is our thought process. Now, diagrams can be written for other situations. Here's a diagram that we wrote for V naught, VF, and delta T. And we found that delta T is kind of hanging out here in the wrong place. Easy to combine with V naught. And it's also easy to combine with delta V. Combine it with, I said V naught. Combine it with V bar to get delta S. So we have this triangle. We could combine delta T with delta V to get A. But of course, this triangle's out there. We have to use curved lines, either that or we have to cross lines. We cross some lines here too, but this is a neater and more compact diagram. And we can see this V naught, VF, delta T thing easily enough. If we know this, this, and this, then what can we do? If we know this and this, we can always get this and this. If we know this and this, we can get this. If we know this and this, we can get this. So there's our reasoning in terms of the diagram if we're given this information. You draw the diagram in any way you want. Straight lines are better, but curved lines, as long as you understand them, are okay.